Students, I welcome you in today's session of physics. And in physics, as you know very well, we were discussing a topic electricity. This is your chapter number 8, clear? And this is lecture number 2. As you know very well, in our previous class, we had covered out electricity. What is electricity? Current electricity, static electricity. Fine. After that, we had also covered the series and parallel combination. Clear? Now topic. So from the meter, the current passes through the main switch to the main fuse. Clear? As you can see here, it is written that from the main fuse, the current is carried to various electrical devices through the connecting wires. So electrical connection use plugs, sockets and switches to ensure a smooth functioning of devices as and when desired. Fine. Now we will come to what is plug. A plug usually consists of 3 pins. I hope you are familiar with the plugs, and everybody has seen plugs in his house. So the two lower terminals pins are connected to the live wires and the neutral wire. The longer and the thicker top pin is the earth pin, and it is connected to the earth wire. Fine. Now we will move to what is socket. You can see here the plug fixed into the socket that has holes for the respective pins. The holes of the sockets are connected to the main electric supply. Clear? It is a socket consists of, you can see here, a socket has 3 holes. The 2 small holes step the electric current, whereas the third and the bigger one is the earth connector. I hope it is clear. Now we will move to what is switch. So a switch is a small device which is used to open or close a circuit. Clear? You know it very well. In our houses we also use switches. It is always connected to the live wire. The front cover of the switch is made of which material? Is an insulated substance such as like bakelite or ebonite. These are the materials which you use for making the switches. Whereas the working portion inside the cover is made of highly conducting material such as brass or copper. When the switch is in on mode, the metal strips inside the switch connects to the live wire and the current flows through the circuit. So when the switch is in the off mode, the connection with the live wire is disrupted and no current flows through the circuit. Fine. Now how would you calculate the cost of electrical consumed? Clear? How do you consumption of? Here you can see that this is the figure of a meter which we use in our houses. So for the consumption of energy or the calculation of consumption of energy is kilowatt hour is the unit of electrical energy for which we pay to the electric supply department of our city. The electricity meter in our homes measure the electrical energy consumed by us in which unit? Kilowatt hours. All these household electrical appliances consume electrical energy at different rates. Our electricity bills depends on the total electric consumed by us or appliances over a given period of time. As much as the consumption of energy by you, as much as the bill you have to pay to the Department of Electricity. So we will now describe how the cost of electricity consumed is calculated. Clear? Since the electricity is sold in unit of which kilowatt hour, so first we should convert the power consumed in watt into which kilowatt hours by dividing it to thousands. The kilowatt are then converted into kilowatt hours by multiplying the kilowatts by the number of hours for which the appliances has been used. This gives us the total electrical energy consumed in kilowatt hour. In other words, this gives us the total number of units. Fine? I hope it is clear. So knowing the cost of 1 unit electricity, we can find the total cost till we become more clear from the given relations or examples. So this is the example. You have to solve this example and tell me what is the consumption you have found out using this. So a radio set of 60 watts run 50 hours. So how much electric energy consumed? Calculate it and then in my comment section kindly tell me. Fine. Now we will move to what is electrical hazards. You can see here, this is the topic we are taking now, electric hazard. So electricity, like any form of energy, must be used judiciously and safely. You have to take some precautions while using electricity, otherwise you will feel a fatal shock. So inappropriate use and negligence in care and maintenance of electrical wiring and appliances can be hazards that may even turn to be fatal. The main reason of electric hazards are discussed below. The first one is the short circuit. In household electric wiring, electric current is supplied through two insulated wires. You know it very well. In our houses, electricity comes through wires and reach each and every electrical appliances. So one insulated wire is called live wire and the other insulated wire is called your neutral wire. As I told in our previous lecture, the wire consists of three wires. One is a live wire, neutral wire and an earth wire. So both these wires are necessary for the working of an electrical appliances, say an electric iron. If the plastic insulation of the live wire and the neutral wire gets torn due to wear and tear, then the two naked wires touch each other. The touching of the live and the neutral wire results of the short circuit. Clear? If the two wires are connected, then you will feel a short circuit. Here you can see the figure of electric press given here, and it is shown in the figure a torn insulation. You can see here. So when the live and neutral wire touch each other directly, then a large current flow through the household wiring. This large current may heat the wires to a dangerously high temperature and fire may be started. Clear? The outer insulation of connecting cable of an electric iron shown in the above figure, as I already show you, and if the insulation of the inner wire also torn, then the short circuit will take place. So we should never use such an electrical appliances having connecting cables with torn insulation. So you please avoid using cables which have a torn insulation. So such connecting cables should be replaced immediately. I hope it is clear. Now we will move to what is overloading. You can see here there is another figure given here for overloading. So when too many electrical appliances are connected to a single socket, here you can see there is a single extension wire and we have connected multiple sockets over the extension board. So they draw an extremely large current from the household circuit. This is known as overloading. Clear? I hope it is clear. You can see this figure number 8.4. The flow of large current due to overloading may heat the copper wires of the household wiring to a very high temperature and fire may be started when a short circuit or overloading occurs. Clear? So the fuse wire block out, cutting off the electricity supply. This prevents the electric fire. Fine. Now there are the few safety components you have to take here. Firstly, this is the topic we are taking now. So every electrical appliances need particular electric supply. So if the amount of electric passing through the devices exceeds the permissible limits, there are chances of short circuit which can lead to the electric wire and can damage all the electrical appliances. So to protect our devices and household against such damage, we use safety devices like fuse, MCBs. Clear? Now we will discuss what is electric fuse. So electric fuse is a device which prevents electric fires and damage to the electric appliances due to excessive flow of current. The fuse for protecting our household electric wiring is fitted just near the main switch, where we insert the fuse just near the main switch or board. So a fuse is work on the heating effect of current. This is the important line. Please remember it. On which principle the fuse is working? So it is working on the heating effect of current. Clear? This one I am again marking here. So we will now describe the working of electric fuse. This is the working of electric fuse. I am skipping this. Kindly read yourself. If there is any doubt, kindly ask me from here. Clear? There is a wire. You can see here. This is the figure of fuse. This one. But the most important thing is its principle. It is work on the heating effect of current. Fine. So just read it, and after that, if you have any doubt or query, kindly ask me in the comment section. So here we will come to the MCBs. What is MCB? Miniature circuit boards. The full form is MCB stands for miniature circuit boards. So nowadays we use advanced fuse, which is called the miniature circuit breaker, or you can say that miniature circuit breaker. This MCB protects the household wiring from the excess flow of current through it. If the current become too large, the miniature circuit breaks put off the switch of the electric supply. The MCB can be reset when the fault has been corrected. Okay? An MCB is placed in series. This is also important. Where you connect the MCB? So you have to connect the MCB in series with the live wire in a circuit and switched on to complete the circuit. Miniature circuit breaker, which is MCB, contain an electromagnet. I hope you are familiar what is electromagnet. Electromagnet is a temporary magnet. So when the current exceeds the rated value of a circuit breaker, becomes strong enough to separate a pair of contacts by putting switch of the breaker. You can see here, this is the figure of MCB, this one. So once the problem is resolved, it can be made functional, fine, by resetting the switch. So unlike fuse, MCB do not work on the principle of heating effect, whereas MCB work on the principle of magnetic effect of current, because there is an electromagnet inside this MCB. So these are the two principles you have to remember for fuse and for MCB. Now we will discuss about what is earth wire. Clear? So we will discuss this in the later of this chapter. At the end, now we will come to, you can see there is a simple experiment. You can perform this experiment simply at your homes or in the classroom. This is the thing given here, this one, you can see. Let's do it. There is a girl combing his hair, her hair, fine, and after combing, there is a comb is electrically charged and it acquire the property of attracting the small bits of paper. So you can perform this activity, and after that you tell me what you saw in the comment section. Clear? Now I move to electric charge. What is electric charge? So about 2500 years ago, a Greek scientist which is called named Thales observed that when a material known as amber was rubbed with a silk cloth, then it started attracting teeny feathers or teeny particles of papers. So Thales said that the amber is a material acquires electric charge on rubbing with the silk. So and the force of electric charge attracts the tiny feathers. We can also show the existence of electric charge or electric by performing some simple activities as follow. Here you can see, as we perform an activity of a comb, same activity we are doing here, where in this case we considered a balloon. If we take an inflated rubber balloon, rub it carefully with a piece of woolen cloth and then touch it with the wall. The balloon, what happened? The balloon stick to the wall. So in this case, when we rub the rubber balloon with the woolen cloth, the rubber balloon gets electric charge due to friction. Fine. This electrically charged balloon then exerts an electric force of attraction on the wall, due to which it starts stick to the walls. So the electric charge which appears on the plastic comb or the plastic scale and on the rubber balloon of woolen cloths are the static electric charge. As I told in the first lecture, there are two kinds of charge. First one is your current charge and the other one is your static charge. So static charge is nothing but the stationary charge, which remain bound to the surface of an object and do not move. Fine. I hope up till now you have understand everything. Now we will talk about what is uncharged and charged objects. So you can see here, this is the thing we are going to discuss. This one. So an object having no electric charge is said to be uncharged object. Body which do not have any charge over it is known as uncharged. An uncharged object does not have any effect on the other object. An object having electric charge, whereas a body which has electric charge is called as a charged object. A charged object has the property of attract other uncharged objects. Like if we take a glass rod and bring it near to some tiny pieces of paper, it will not bring it near some tiny particle of paper, it will not have any effect on them in case of uncharged. But if there is a body of charge, then it has the property to attract the paper towards itself. So these observations can be explained by saying that the initial glass rod is electrically neutral or uncharged, but when it rubbed with the silk cloth, then it gets the property of charge and attracts other particle. I hope you understand it. Now we will talk about what is static and atomic structure, static charge and atomic structure. So you can see here, all the objects, whether it is glass, rod, silk or cloth, rubber, balloon, etc., are made up of tiny particle which is called atoms, and all the atom consist of two type of electric charges inside them. First one is your positive electric charge which is called protons, and the negative electric charge called electrons. So in an uncharged object, the number of positively charged particles proton and negatively charged particles electron in the atom are equal. Then what happens? The equal number of positive and negative electric charges balances each other and make the object electrically neutral. You know very well the atom is electrically neutral. The positively charged protons are held strongly inside the nucleus of the atom. So protons cannot be transferred from the atom of an object. Only, as I told you, free electrons are responsible for the conduction. Only electrons on the outermost orbit or the shell of the nucleus are responsible for the flow of electric current. Clear? So that is the thing given here. Now there you can see here, there are the two electron can be transferred by the atom for one of the to another object by rubbing. Fine. So if you rub the two objects, then electron can be transferred. Now here are the 2 points given. Just read it. The object which loses negatively charged electron during rubbing acquire positive charge. Fine. If an atom or a body loses negative charge, then which charges it acquire? It acquire positive charge, because then the number of positive proton it become more than the number of negative electrons. Fine. Now we talk about the second one. The object which gain negatively charged electron during rubbing acquires a negative electric charge. Which gain negative charge during rubbing? It acquires a negative electric charge, because the number of negative electrons it become more than the number of positive protons. So whether an object will lose electron or gain electron during rubbing depends upon the nature of the object or the material. So the material like glass, wool and clothes, hair and ball pens, refills loses electrons more easily and hence get positively charged on rubbing. On the other hand, the material like silk, rubber, balloon, plastic, comb, polythene, these are negatively charged during rubbing. Now we will discuss about the behavior of electric charge. Fine. I hope till now you understand everything. So students, this topic, the behavior of electric charge, we will discuss in our next lecture. Fine. And from this we are ending this class. Thank you class. Thank you very much.